Now that you have learned what a common logarithm is, I will now teach you what a natural logarithm is. Natural logarithms are logarithms with this special base, e. What exactly is e? E is called Euler's number, which is approximately 2.73. You can treat it like any other number like pi. It is an irrational number. The short form of the logarithm of base e of x is ln x. Please do not pronounce this as in. It is ln, short for ln. So to convert the natural logarithm equation y equals to e to the power of x into its logarithmic form, we simply ask ourselves again, how many times do I have to multiply e in order to get y? I need to multiply e x times, therefore the logarithm is x. So I will get x as the logarithm of base e to y, or in other words, ln y. You notice that log base e is replaced by the two letters ln. Once again, the base is Euler's number or e, and the power is x. Base at the bottom, power on top. We do not write log base ey. Instead, we write ln y. Let's take a look at a few examples in order to apply the concept of the natural logarithm. Let us solve the following equations. For instance, if I'm given ln x equals to 2, we simply change this to log base e of x equals to 2. And from here, changing this to the index form, we will get x equals to e squared, which will give me approximately 7.3890. And I can change this to 3SF to be 7.39. Similarly, change this to log base e, bring e over to get e to the power of 5, and you can solve for x. Remember to change your answers to 3 significant figures. Now, what if we get a question such as this, where we have a mix of the natural logarithm, the common logarithm, and this number over here? Now, don't fret, it is actually pretty easy. All you have to do is just change this into logarithm, the logarithm of base e. So we'll change this. Once again, we bring e over, log 2 becomes the power. Now you can easily key this into your calculator. I will show you how now. Alright, after keying this into your calculator, we change the common logarithm. You will get 1.3512, approximately there. We will truncate it up to 5 significant figures. After this, we will change this LG to the common logarithm. Please do not be mistaken to divide this over. This is logarithm. You cannot divide this. So we will change this to the common logarithm, logarithm of base 10, and similarly, we will bring the 10 over to get 10 to the power of 1.3512, and this will give us approximately 22.449, which is x, which gives us 22.5 to 3 significant figures. Here are some special properties of logarithms that you need to remember. Let's take a look at the first one. For instance, if I'm given a log base a of 1, this will immediately be 0. Why? Let us ask ourselves, how many times do I need to multiply a in order to get 1? The answer, or the logarithm, is 0. Therefore, the logarithm of anything to the power to 1 itself is actually 0. Similarly, how many times do I have to multiply a in order to get a? I multiply a 1 time. Therefore, the logarithm of base a of a is always 1. Take note, for the base e, this is a special case of this, where a is actually equivalent to Euler's number. So I will have log base e of 1, which is ln 1, to be 0, and ln e is simply 1. Let us see how we can apply these special properties to evaluate sums without using a calculator. Let's take a look at the first one. We have just discovered that the logarithm of anything to 1 is always 0, and the logarithm of any two similar numbers here will always be 1. So substituting this in, 0 plus 3 times 1, that will give me 3. And for the second one, to simply evaluate this, take a look at these two numbers here. They are the same. So this would give me 1. So I have 5 times 1 to the power of 7. This is just log base e of 1. And we talked about it. When the number here is 1, this will give me 0. And ln e itself is just 1. Keying this into the calculator, I will get 14. So, thank you for watching this tutorial.